subscribe to my channel and press the bell icon for the latest video updates. Hello everyone, welcome to my channel on learning field. Today we will derive the equation for capacitance of a parallel plate capacitor. Please watch the videos till the end. So let us derive. First of all, we need to draw two parallel plates, one having positive charge and another having negatively charged. The distance between them is d, and this negatively charged is connected through ground, and this one is plus q and this one is minus q. Let the surface charge density be sigma. Then let us first of all write the consideration part. The parallel plate capacitor consists of conducting two parallel conducting plates. Two parallel conducting plates. Each of area A, separated by a distance d, having surface charge density that is sigma. So the medium, this is the sigma, so the medium between them in air, okay, therefore a charge plus q is given to the first conductor it induces a charge minus q in the second plate. Okay, which is earth head, isn't it? So we can write the electric field is starting from positive plate towards the negative plate. Okay, and are perpendicular to the field. Now I think you have understood the consideration part. First of all, what we have done, that we have considered two plates, one is positive, one is negative, and charge plus q and minus q. The distance between them is d, and we have considered a surface charge density that is we have considered sigma to be a surface charge density, isn't it? The medium is in air and we have earthed with the earth. Okay, and now we need to write the derivation part. By the application of Gauss law, since we have studied about Gauss law, isn't it? Gauss law states that the total flux of the electric field, E over any closed surface is equal to the net charge enclosed by the surface. So we can write E is equals to sigma by epsilon naught, isn't it? This surface charge density, since Q is replaced by surface charge density, instead we used to write here Q, isn't it? So we can write E is equals to sigma by epsilon naught. Now the potential difference between the two plates, will be, since potential difference means what? Potential difference formula we have studied, isn't it? Potential difference is equals to E into ds, or dr also you can write, isn't it? Potential difference is equals to E into ds or dr. So to find the total potential difference we need to integrate, isn't it? So we can find V is equals to integration of limit is from, you can look here, the limit is from d, isn't it? The limit is d, from d to 0, minus of EDR. Since potential difference is of minus, we have already proved, minus of EDR. So we can write V is equals to integration of d to 0. Since we have shown that E is equals to sigma by epsilon naught into dr, so we can write V is equals to, these constants will come out and what will remain here? Only dr. So minus of sigma by epsilon naught integration of d to 0 into dr. So if you know to integrate, you can integrate this one. If you don't know, I'll explain you now. Now integration of dr, if you see, the lower limit is d and the upper limit is 0. So how to integrate this one? First of all, let us cancel these terms, d and this one. So what remains here? Only r. So limit is d to 0, isn't it? So we can write V is equals to minus of sigma by epsilon naught into, from, we need to integrate from 0 to d, upper limit minus lower limit. What we need to do? Upper limit minus lower limit, u minus l. Okay, 0 minus d, this is the upper limit, this is the lower limit. Upper limit, this one is lower limit. Okay, so what is the integration? Integration is from upper limit to lower limit. So upper limit is 0, lower limit is d, so we can integrate this one easily. So therefore we can write V is equals to minus of sigma by epsilon naught into minus of d, isn't it? So V is equals to plus of sigma by epsilon naught and into d. So we know that capacitance is equals to Q by V. Capacitance is equals to Q by V. if you have not learned, you will be learning soon about capacitance. Okay, so just you remember the formula. Capacitance is equals to charge by potential difference. Okay, so we can write this one. Now we need to, what we need to do is that we need to substitute the values. We know that surface charge density is equals to, we know that surface charge density q is equals to sigma into a, or you can write sigma is equals to, isn't it, we have already shown in the chapter 1 this one, q by a, this one surface charge density, and we can substitute the values here. So we can write c is equals to, instead of q we can write sigma into a, and instead of v we can write, since we know that potential difference means what, potential difference we have already found this one, sigma into d by epsilon naught. Just we need to substitute the values here, sigma into d by epsilon naught. So c will be equals to sigma by sigma into a, sigma into d. This last term will go upside. So c will be equals to, this sigma and sigma cancel, and what remains here, a into epsilon naught by d, isn't it? So this is the required proof, isn't it? Hence derived, hence derived. This is the required proof we need to do. So how we have integrated? We have integrated from upper limit to lower limit, isn't it? So first of all, what we have done is we have found the potential difference between the two plates. We know that the formula of potential difference, V is equals to minus of EDR. Since V is equals to minus of EDR, we know that electric field, we have substituted the values of E. Since we have, by Gauss law, by the application of Gauss law, we know that E is equals to sigma by epsilon naught, isn't it? So we can write sigma by epsilon naught, this minus sign came out, and this sigma by epsilon naught is also constant, so we came out this value, this value came out. So we have integrated with we have found the limits from 0 to d, upper limit minus lower limit. So we have subtracted and we have got the value, substituted the values here, and hence derived. If you understood, please like, share and comment my video. Thank you.